Hello, Algebra students. I hope everybody's doing great. We are continuing in Chapter 8, and we are in Section 8-6, Day 1. What I'd like for you to be able to do by the end of this lesson is to factor a trinomial by grouping when the leading coefficient is greater than 1. So we're going to be talking about a new type of problem where there's going to be something different about this. What happens when that expression that we have begins with something other than 1? So in all of our other expressions, it looked maybe like this, x squared plus 7x plus 6. And notice how there's nothing in front of this x squared, so that would be an invisible 1. But what happens when we, put a 2 in front of that or whatever? How are we going to handle that? Because that's a totally different problem. So that's what we're going to talk about here. So these are in the form something called ax squared plus bx plus c. So the a would be the 2, the b would be the 7, and the c would be the 6. And then their x squared and x are just what they are. And the only new step is this step 1 right here, where you multiply a by c. So you take your leading coefficient and you kind of draw a rainbow arch over to the last number and you multiply those together. So this would be 2 times 6, or in our given example, I have 6x squared plus 11x plus 4, so I'm taking 6 times 4. Now, you're finding numbers that multiply to whatever number you multiplied. So 24 was that number that we got. You're going to find numbers that multiply to 24 and add to your middle term still. So what are some things that do that? 3 times 8. 3 times 8 equals 24, and 3 plus 8 equals 11. So that part's staying the same. After that, you're going to split up your middle term. So instead of writing 11x, I'm going to write 3x plus 8x. Then you're going to split it up into your front and back half. So we have the front half and the last half. You pull out a GCF of either term, and you have a remainder in parentheses. Notice how the parentheses match, and then we rewrite for our last part. All of that stuff is exactly the same as what we were doing before. The only new step is this part of multiplying the leading number by the last number. So let's put that into action down here in example A. Now I will say example A is a little bit special because it has a GCF, so we want to pull that out. So I noticed just from looking at this, 15x squared plus 33x plus 6, they all have a factor of 3 in them. So I'm going to go ahead and factor that out because I don't want that 3 making my life even more difficult. So when I pull a 3 out, what do I have remaining when I divide it out? I have 5x squared plus 11x plus 6. Okay, now this is the expression that I'm going to be focusing on, the part in parentheses. And your new thing, this new step that we have, we need to take this 5 and we're going to multiply it with that 6. And that's going to get us positive 30. So now we're looking for things that multiply to 30 but add to 11. So 1 times 30 equals 30, or 2 times 15, or 3 times 10, or 5 times 6. And notice this 5 times 6, that's going to be our magic pair. Now I'm going to take that 5 and 6 and rewrite my middle term as those two guys. So I'm going to write 5x squared plus 5x plus 6x plus 6. And all that's still in parentheses, and I still have a 3 up front as well. Okay, everything else is the same from this point. So look at your front half. And then look at your back half of your problem. For the 5x squared plus 5x, what do both of these terms have in common? They both have a 5 in common, but they also both have an x in common. So this 3 is still up front, and I still have that parenthesis, and I'm pulling a 5x out. Now, when I pull a 5x out, I'm asking myself, what do I have remaining? So when I pull that 5x out of this first term, if I pull 5 out of 5, I don't have any numbers left. I'll have a 1. And then if I pull x out of x squared, I have an x remaining. And here, what is 5x divided by 5x? Well, that's 1, so x plus 1. Now look at your next expression. What can I divide out of both 6x and 6? I can divide a positive 6 out. But what do I have remaining? I have x plus 1 remaining. All right. So now we have matching parentheses of this x plus 1. We rewrite just like usual. This 3 is still hanging out up front. This was kind of a weird problem to lead with, but whatever. So I've got 5x plus 6 for one set of my parentheses. And then I've got x plus 1 for another set of my parentheses. And that's all. It's still the same process. It's still the same steps that we've been covering. We just have that one extra thing, and there's not really a shortcut with this one. We have to follow the steps all the way through. So let's do that again in example B. In example B, we don't have a GCF, so I'm just going to take this 2, the leading number, and multiply it by the last number, 15. When I take 2 times 15, I get 30. So now I'm looking for things that multiply to 30, but add to 11 again. So this is actually kind of similar to that previous one, but whatever. I'll still list a few out. So we've got 3 and 10, or 2 and 15, or 6 and 5. So I'm going to use this 6 and 5 because I know 6 plus 5 gets me to positive 11. Okay, so now I'm going to rewrite this middle term as 6x plus 5x. Carry down your plus 15, carry down your 2x squared. Now you want to look at the 2 halves of your problem, the first half and the back half. So the part underlined in yellow highlighter, 2x squared plus 6x, what can be divided out of both of those? You want to temporarily ignore this part. So if you have 2x squared plus 6x, they both have a factor of 2, and they both have an x in them. So I can pull 2x out of that. But when I pull 2x out of that, what do I have remaining? Well, for the first one, I still have an x left over. And then for the second one, if I divide a 2 out of 6, I have 3 remaining. And if I take an x out of x, then I don't have any x's. So I've got x plus 3. Now, for the part underlined in pink, pull the GCF out of that one. I can pull a positive 5 out of both of those. And when I do, I've got x plus 3 remaining. Alrighty. So now I'm ready to rewrite. My parentheses that match is going to be one of the terms, or one of the binomials. And then when I factor that out, I'm literally factoring out the parentheses from the first half and the second half. What did I not factor out yet? I need that 2x plus 5. And there we have it. Now you are able to check these just like you are the other problems. If you want to check your work, go back and FOIL them out, or just multiply the 2 binomials back out to make sure you get back to your original problem. For example C, I have 4x squared plus 25x plus 6. Step 1, the new step that we have, is to take this 4 and multiply it to that 6. When I take 4 times 6, that gets me 24. And now I'm looking for things that multiply to 24. So example 2 and 12, or let's see here, 4 and 6. Or we also have, let's see here, 1 and 24 as well. We've got a couple of things. But okay, so I want to use the 1 and the 24 because they need to add to this middle number. So I'm going to take this 1 and 24 and rewrite the middle number into 4 terms. So, or the whole expression into 4 terms. So I have 4x squared plus 1x plus 24x plus 6. Now, I'm splitting this up into 2 halves. And first looking at the part underlined in yellow, 4x squared plus 1x. What can I divide out of both of those terms? I can divide an x out of both of those terms. But when I divide an x out of 4x squared, I still have a 4 remaining, and I still have an x left over. So I've got 4x. And if I take an x out of 1x, well, I still have positive 1 remaining there. So I'm going to say plus 1. Okay, now I'm factoring the back part, or I'm taking the GCF out of these two. So what is something I can divide out of both 24 and 6? Well, I can divide 6 out of both of those, so I'm going to put plus 6. But when I divide 6 out of 24x, I have 4x. And when I divide 6 out of 6, I get positive 1 still. Okay. Notice once again, these parentheses are matching. That's good news for us because that means that we did it right and we're able to do our final step where we rewrite. So one of my parentheses is going to have 4x plus 1 and the other binomial will have x plus 6 or will be x plus 6. And there we go. Okay, we're going to do example D. Skip these two because we're going to do them in class at a later time, and then I'm going to jump down and do another one with a GCF real fast. So let's do example D. First step, same as usual, take that 7, multiply it by the 2. 7 times 2 is 14. So I'm looking for things that multiply to 14. So for example, 1 and 14 or 2 and 7. Okay. I want the pair that also adds to this middle term 15. So I'm going to use this 1 and 14 right there because 1 times 14 multiplies to 14, but 1 plus 14 adds to 15. So now take this middle term and rewrite it as two things. So I still have 7x squared and then plus 1x plus 14x plus 2. This 1x and 14x is that 15x split up. Now I'm looking at the front half and I'm looking at the back half. Focusing on the part underlined in yellow, what does 7x squared and 1x have in common? In other words, what am I able to divide out of both of the terms at the same time? I'm able to divide an x out of both of them. So I'm going to put x, but then what do I have remaining when I pull that x out? Well, I have 7x plus 1. Okay, now I want to do the same thing of factoring this back part. So I'm going to factor out a positive 2, and I have 7x plus 1 here. Now I'm factoring out a positive 2 because that's the most that I can pull out of both of those terms. So that's how I did that. For my last part, I'm going to rewrite. So one of my parentheses is 7x plus 1, and then another one of the parentheses is x plus 2. So as you can see, this process, very, very similar to what we've been doing already. There's not a shortcut for this one, okay? This one's a little bit more difficult. We'll do these future ones in class at a later time. We're going to skip down to example A, and this one says sometimes you can factor out a GCF first, then factor by grouping. So there was a little bit of a typo. I want you to have 12x squared plus 84x plus 72. And on this guy, there is a GCF. I can take all of these terms and pull a 12 out. So I want to do that to make life a little bit simpler. So if I pull a 12 out, then I have x squared plus 7x plus 6. Now I'm looking at my trinomial, and hopefully you noticed, oh, hey, this has a leading coefficient of 1. It's that invisible 1. So I don't have to do this whole process. I can go back and do that little shortcut that we noticed from previous units where we said, okay, let's find multiples of 6. So that would be 1 and 6 and 2 and 3. Which pair also adds to the middle, 1 and 6. So now I can just pull those numbers down into my parentheses. But I still have this 12 floating in the front. So I'm going to have 12 and then 2 sets of parentheses, an x in the beginning of both of them. And I'm only able to do this shortcut because the leading coefficient was 1. Remember, in all of these other problems, I got 8 and 9 and 4, things that are bigger than 1, okay? But here, when I factored this 12 out, my leading coefficient became a positive 1. So that's why I'm able to use this shortcut here. So I'm going to pull in my numbers now that I discovered. And so I've got x plus 1, x plus 6. There's your solution. and we're going to call it a day. So we'll do this example in class at a later time as well. I hope you have a great night, and I hope to see you soon.